One of the problems, traditionally with doing audio and installations is how to get rid of the laptop. If you can get rid of the laptop, you don't have to leave a laptop there, which is expensive in an art gallery. You also, a lot of times, the more complex your computer, the more likely it is to go to sleep, have problems, etc. So the least complicated device you can ever use in art installation is always the best. The problem, though, is with microcontrollers historically was latency. As a musician or with something, you want to hit a control surface and you want to instantly hear it. And latency is always a problem in audio, and especially if you try to use something like a Raspberry Pi or an Arduino, they're going to have a latency problem where you hit something and then you have a perceptual lag before you actually hear the tone, and that can be problematic. So I'm going to talk about, there's a couple of solutions now that there weren't 10 years ago. This morning, Francisco talked about the Daisy, which is a low latency audio platform. I'm going to, I think that's based around the ESP32. I'm going to talk about Bella, which was developed at the University of Nottingham in the UK by a couple of graduate students and the professor there. And they're available on the market. We have one here that comes in a small size too. Basically, it's based on a BeagleBoard. So it's a shield on top of a BeagleBoard. A BeagleBoard is a Linux computer on a chip. So it runs a 1.2 megahertz general purpose processor, and it's running Linux, but it's running a real-time version of Linux. So it's optimized to be running in real time. And then it has the hat on top, which, just like an Arduino, it's going to give you all your GPIO in and out. It does stereo audio at 96 kilohertz in and out, and it can do up to 8 analog ins and 8 analog outs. So a lot of capability for a small board there. This also has Ethernet on it, and from the BeagleBoard, the smaller versions don't. And you have speaker amps on there, but I never use them. I always use the small versions. I just grabbed this for the demo. And also kind of part of the Bella ecosystem is really good capacitive touch sensors. They've also, because they are musicians and they're working to develop stuff for making musical instruments and making experimental musical instruments in platforms, a lot of that will involve capacitive touch. All my examples today involve capacitive touch, and capacitive touch is a nightmare. So but their sensors are very well designed. Let me turn on the projector here. So that is one of the advantages there. And the other thing is that it has a very friendly IDE. So you can program in a variety of languages for it. C++ is my preferred, because I know it, and I've been programming C++ for 20 years. But also takes pure data, which is much more accessible to most music students, because this is pretty much a free version of Max MSP. So you can program in a more visual language like that. You can also use C Sound, which is a classic, I've never used C Sound, but it's a programming language that's been used in music since the 80s, and it's usually part of community music. So it will take that too. And there's one other, I forget, but the support for both C++ and pure data is really robust. So you have an IDE, you just go to bella.local, and I'm not going to go into the details how to use this. I'm just kind of trying to show in 8-10 minutes what the basic purpose of the platform is, so you know it exists if this is something that would be useful to you. And it's, unlike the Daisy, which doesn't really have an IDE, you can see what the errors are down below. You can actually, because it's a Linux computer, it's running this web server, and I'm actually, you can actually see it in real time. And basically, I just have some basic code here. I have 3 of these touch centers, each playing an octave, and it's C++. You can see it all classes. And the example codes are very good, and there's forums it's a small user base, but they are very responsive, and the professor who made it will always usually respond within 24 hours if you ask a question on the forum. The guy has no life, I guess. But it's just I'm why are you responding? It was a simple question, someone else could have responded. But each of these touch sensors are kind of nice because they can do everything set up for polyphonic sound. So it will do 1 touch, and then it will actually detect 5 touches, and also will detect how strong you touch, which is actually really nice for capacitive touch sensors, not just on off. And if you have multiple hooked up, you can do 15 at once. So it can be very responsive that way. If you look closely at the sensors, you can see that there's just a sawtooth pattern on there, and it's actually just 30 touch pads in a row. And so and then it can kind of figure out by the little chip on the board on the back here, which one you're actually touching and how strong by how many of the ones next to it are being touched. It will determine how strong you're touching it and not actually play those other tones, but that. So you can get continuous tones. Right here, I'm just taking a few detuned oscillators. So yeah, you can have like 15 touches at once, and with this setup, you can keep on doing them, and each touch is doing 4 oscillators, and it's not even stressing the CPU out. It's at like, it's not showing me real time. It usually shows you right there and shows you how much CPU you have left, but this is, the C++ code runs pretty efficiently. The pure data, not as efficient because it's turning it into C++ before it's actually running it, so the pure data I've had run out of frames and had to drop frames, and you can hear that in some of the other projects in the other room. So I just kind of wanted to show that real quick, and just kind of overview. And I also kind of want to like say like, when do you want to not use this but use something else? Like you can see that this doesn't sound that great. You know, it's a couple oscillators, and I could put. And generally, the old trick is always to add some reverb and some delay, and anything will sound good. So, but if you can, and I have programmed reverbs in here, but like reverb and time-based effects are computationally intensive because you're writing to memory. There's a little tricks with like kind of you have to learn with programming this, and there's very nice YouTube like 10-week classes up on like, okay, here's the pure data, here's C++. But you have to kind of make your code more efficient, so you have to remember those comp sci lessons from like 20 years ago, or if you're me, I'd be like, oh, I didn't pay attention to computer algorithms. How do I make this like more efficient? And then you also have to worry about like your memory buffer, because you're writing to a buffer and you only have a couple milliseconds to get it out of the buffer before you're going to start dropping frames. So if you're doing it with delay effects, you're going to be using up the memory on the chip really easily. So another option, which has gotten more approachable, it's still a little bit more advanced, is using a dedicated DSP for time-based effects. The one I've been playing with a lot is called the FV1 because it's about 15 bucks, and it's used in a lot of guitar pedals commercially, and it's gotten a lot easier to use. A DSP, you basically buy a chip and you're gonna have to solder onto a board. There are DIY boards out there now, so you don't have to buy the expensive development board. And you're going to have to burn an EEPROM. The FV1 has been around since 2003. It runs at 48 kilohertz or megahertz. Not very, like, it looks like a potato on paper, but its instructions are only meant to do time-based effects. So its instructions are so much more efficient than a general purpose processor. So because it will be actually, it has instructions for delay and for like reverb type algorithms. So you are writing in assembly most of the time, but you have to remember what an accumulator is and all this stuff it's kind of horrible. But there have actually been tools I want to show now that have actually made it a lot easier. Someone wrote a Java program that makes it look like pure data, and you can actually just kind of like, okay, well, I'm going to put my input here, input goes there, my output goes there, and I can program my effects for the FV1 relatively simpler. Okay, I want a reverb. How about room reverb? We'll throw that in the center, and I can draw my lines from the input. And then the output, and I have mono, and it can take up to 3 potentiometers, but potentiometers on these are just set up as so it's a little limited. You can only have 3 variables, basically. And it doesn't have to be a potentiometer, like it's just anything from 0 to 3.3 volts, so you can put a sensor there. Anything that's an analog sensor or output 0 to 3.3 will work with it. But yeah, you can just basically, this is not something we'll go into depth here, but like you can just okay, I'm just gonna drop my a mixer in, or all these basic things there, and then you can right click on them and just go into the details and make custom effects this way. So when you're like for me, like when I'm putting in like reverb or delay into like an installation, I will generally put it onto a chip like this, and then put that behind, and then so I'll be making my bass tones with this, and then running it through basically a pedal chain where hopefully they won't see it, but I can run my reverb and delay through that instead of on the processor itself, just because it's more efficient and sounds better. Less likely to drop frames, and will sound better. And that will generally make something that sounds like this sound a little bit better. So I think we're all walking in and showing in the other room, so we can just unplug this and I'll show this how this all works. These are capacitive touch, but these are running off of a Trollcraft, which has 30 input outputs. I did the ridiculous thing of hooking up the fruit, because everyone has to do that once with capacitive touch, so I've done it for you. But this is just playing samples through pure data, and then we're just running it through like the FV1 chips over here to make it like, delay reverb sound. To kind of warm up this should have booted by now. See this boot yet? Oh, it's booted. Come on. Sometimes one thing with this is it takes a minute to start up. And then the fruit. Yep. Because fruit is just full of water, so I'm just having it wires up to the touch controller. So it has capacitance in it, so you can actually just, play with vegetables. And these are just doing the same basic thing with the oscillators, making basic tones. And basically, most capacitive touch sensors suck, and you should never do this with the capacitive touch, because the longer your wires are, the more stray capacitance comes into the world and it'll drift. But when it boots, these boards are really nice for their cost, because they auto-calibrate every single channel to its current capacitance. So it will make that 0, and then as soon as any other additional capacitance comes on, it makes that the value. So it auto-zeroes out everything. And if you're doing something like fruit and stuff, it'll drift. But these, I built with like really narrow wires. It's like in the back there. And if you have a metal plate or something that's more substantial with capacitance on the end of it, it's going to be less likely to drift. If you make this out of copper foil, it's going to drift more than if you put like a chunk on the end. So now, like, just adding some reverb and delay just makes anything sound better. And then, like, when you're doing like installations with like sound installations for the public, one thing I always like to do is like give them some choices, but kind of control their choices. Like I just use a pentatonic scale, which will sound good in any notes that you play. So this is just a minor pentatonic. So any notes they hit will sound like they're in key, so they can't like strangle cats. Like so maybe putting some guardrails on there when they're not musicians who are going to be playing it is like, you would set up guardrails like that. If you were making it for a musician, you would give them more tones, but if I only give them one scale, then they can't like, oh, I'm just iterating the buttons, it all sounds like it's in tune. So pentatonic scales are your friends when you're dealing with the general public, because no one wants to hear them like play sour notes, which is harder when you do something like this, because it's like really easy to make terrible sounds. That's thank you. If you have any more questions, I'll be around all day.